Okay, example 2 is 5x minus 4y squared plus 24y minus 11, the equation of a parabola, hyperbola, or an ellipse. Okay, so if you take a look at this one, what I'm noticing specifically is I got the minus 4y squared, so I'm thinking maybe a hyperbola, but there's no x squared. So just y squared, no x squared tells me it's a parabola. So again, characteristics of general form allow us to establish what kind of conic section it is every time. It is a parabola, so we want to get parabola standard form. We have a y squared structure here, so I'm looking for y minus k squared equals 4p times x minus h. We always got the 4p times the non-squared object. So let's make this happen. So first off, I'm going to divide everything by -4, even if it doesn't divide nicely, because I don't want anything in front of my y squared. In fact, I want a positive y squared. So divide by -4, I get -5/4 x plus y squared minus 6y plus 11/4 equals 0. So every sign changed to its opposite. Everything got divided by 4. Things divided evenly by 4, divided evenly. Those that didn't stay as fractions. Everything that isn't y now goes to the other side, so I'm going to keep y squared minus 6y on the right. I'm going to leave a gap to complete the square. I'm going to move the 5/4 x becomes positive, and the 11/4 becomes negative over to the right. Once again, I want to complete the square. Completing the square comes down to the squared object. Again, y squared, 1y squared, we're allowed to do it. I'm going to take half of 6 is 3, 3 squared is 9, so plus 9. Over here I'm going to say plus 36 over 4, just for the sake of a common denominator. That gets me the quantity y minus 3 squared. Keep in mind the perfect square trinomial we create, we take a square root, a sine, and a square root from the 3 pieces. The parentheses squared happens there. Altogether here I got 5/4 x plus 25/4. Now, looking at my standard form structure, there's just an x in here, not a 5/4 x. So whatever's in front of x at this point, I'm going to factor that out, even if it's ugly as this is. So y minus 3, the quantity squared, is going to equal 5/4 parentheses. Of course, x on that one, right? And if I take 25/4 and divide it by 5/4, divided by 5/4 is the same as times 4/5, we get 5. So even though we have a somewhat an ugly common factor, it makes a pretty nice looking expression there. So, just like that, I've got my standard form created. So I need a vertex, I need a focus, I need a directrix, and I need an axis of symmetry. Vertex and focus are points, directrix and axis of symmetry are both lines. The vertex is going to be change the sign x first, y second. So change the sign -5 for x, change the sign +3 for y. 1, 2, 3, 4, 5, 1, 2, 3. I know for a fact that 4p is equal to 5/4, which means p is equal to 5/16. And p is positive 4p is positive 5/4, so p is positive 5/16. The focus is the direction we go. So 5/16 would be like, I don't know, 0.3125 maybe? 5/16. Oops, 16.
Yeah, 3125.
0.3125. All right, so 0.31 over to the right. So not very far. Like, in fact, that point's so big I can't barely get in there. Let's make this point smaller. So 0.3125 would be about here. Little blue dots there, you can barely see them, but there they are. Okay, and directrix is going to move vertically for a y squared object, and it's going to be 0.3125 to the left. We draw our directrix as a vertical dotted line. Keep it blue. So about 0.3125 over to the left. The axis of symmetry goes through the focus and the vertex. I'm going to make that a little thinner. Let's make it a different color and move it to the back. Oh, that's too far back. Let's see. Not all the way to the back. Let's move forward. There we go. All right. I still see my blue dots there. Okay. And the final thing I would do is, since 4p is equal to 5/4, I go half that much up and down. So half of 5/4 is 5/8, which is 0.625 or 63. So at the focus, I'm going to move 0.63 up and 0.63 down. I want those points tagged in. 0.63 about here and about here. And that creates my dots that I'm going to connect to create my parabola. So I create my parabola going off like so. As far as identifying the focus directrix, the focus I moved 0.3125, so 0.31, right? So to the right, so y is staying 3. If I take -5 and add 0.31, I get -4.69. As far as the directrix is concerned, I'm moving that way. I'm getting the x equals equation. This is x equals -5. We move 0.31 to the left of that, so x equals -5.31. As far as the axis of symmetry is concerned, y equals, and it goes right through the y coordinate, which is 3, so y equals 3. So we identify the vertex, focus, directrix, axis of symmetry, we create our graph of our parabola. Okay, that's what we're looking for in a parabola problem. So anytime you get a parabola problem, once you've established a parabola, that's what I'm looking for. Correct graph along with all the pertinent information about it.